Okay, thank you very much. I am Erwin Varga, and as mentioned here, it's Expert IT Consulting. It's my consulting company. But also I am an associate professor at the University of Novi Sad in electrical technical faculty and on the Department of Applied Software Engineering. So I'm 50-50, I'm both consultant and academic person, so knowing the software industry from both sides. The Zen of Python in action, aiding large-scale Python software systems. Now, the Zen of Python, that's something I am going to explain. In action means that everything what you will see in the list of Zen of Python is going to be exemplified. And aiding large-scale Python software systems, this talk is about large-scale software systems and how Python and Python developers should take their role and place in large enterprises. Because it's easy to develop small-scale software. It's easy to come up with programming languages which are very good under laboratory context. But we will see how Python needs to address the challenges of large-scale development, and some of these challenges or some of these things have already influenced Python and Python's direction where it goes. So let's start. The first slide is about wagon poetry. Have you heard about wagon poetry? Yes. Okay, cool. These guys read Hitchhiker's Guide to Galaxy. Now, for those of you who don't know what is wagon poetry, there is a warning sign here, which means that this talk might turn into the wagon poetry. And these guys who knows what is wagon poetry knows what they are waiting for. So why? Because it's very hard. I mean, the topic is hard, extremely hard topic, okay? It's not a topic about latest, coolest, funniest things what you can find, but it's about core fundamental principles of software engineering and how it maps to Python. And this is very good because in these hard topics, we can see how things are rolling and why anything, when you see something on the surface of a language that has deep root cause in the software industry and why it's working like that. What is more harder? To exemplify a hard topic. It's easy to talk in abstract terms, but to exemplify and come up with simple examples, that's the harder part. And what's the hardest part? Well, to avoid completely losing the audience. Okay, that's the hardest part. And because of this real risk here, I needed to model how many slides to prepare. That's a modeling session, right? So you first need to come up with a random variable representing how many slides presented before losing the audience. Okay, that's a random variable. You need to model it using the geometric probability mass function, and then you calculate the expected number of x, which is the expected number of slides I need to prepare. But guys, this is an expected number, right? So when you're rolling a dice from 1 to 6, what is the expected number? Is 3.5. Even if you round it up, it's still 4. And what if everybody stays, then what? Okay, that's a new risk. You need to mitigate this new risk. And end up, you either give up or hope for the best. And I have chosen this second thing, so I haven't gave up. Okay, I am here. But guys, buckle up and let's survive this talk, okay? Table of contents. So it's very important for you to know what's awaiting for you. So first we will very briefly talk about the characteristics of the large software systems, large-scale software systems. It's very important because that's a common denominator on which the rest of the talk will be based. And it will be very brief, I promise you. This is the only abstract part, couple of slides. Please be buckled up and we will then go to the examples. Then a rule of rules, principles, conventions, and standards. This is something very important for large-scale software systems. You cannot just hope for the best that everyone will follow some imaginary rules which will just turn up to be good for everybody. Then context awareness and communicative abilities. This is something which is extremely important for young people, especially. And I'm very glad that you are here. I see a lot of young developers, and we will see how things are different in an enterprise than what you think or what you have experienced in an isolated environment or in small teams, okay? Then we will talk a little bit about handling legacy code from the viewpoint of why documentation is important. And these two guys here are marked in different colors, which are just touching on the surface of these. And these two combined would, in order to make justice to these topics, I would need another Wagon poetry of 1 hour, okay? But that would be too much for you to listen at once. Okay, so let's see the characteristics of a large software system. We have here a software. Now, when people talk about software and software lifecycle, you have a software and software development, right? That's one-on-one, because in order to come up with a large software, you will have a formalized software development process behind. But we will see that with large-scale software systems, a lifecycle is a bit different than a one-shot system. So here is a Python code, and to explain the lifecycle, guess what we are going to use as a model of chess? Okay, so we will use a model of chess, a tournament chess, by the way, not an amateur chess, because chess has a planning part, has a theory, has a practice. I was a former chess player, so you need to optimize your resources, balance between resources and positions, a lot of things which are very good resonate with the software. And these are the life cycle of a chess game and the software development. So we have here a preparation. When you are in a tournament, you prepare for your next opponent, you see his playing style, decide whether you want to win or lose. You prepare, actually make a plan for the future evolution. And that's the same thing when your requirements, when you're scoping the system, when you're gathering stakeholders together, defining the mission and vision. That's where you plan, basically, what will happen with your software system. Then we have an opening, and that was the first thing. Then we have an opening and design. That's the place where you either can make a very good move or screw up everything. Because in chess, if you make a mistake in opening, everything else is a struggle for the draw. And the same thing with software systems. If you make a mistake in an API, and then you need to just deprecate it or support it, but anyhow, the damage has been done. Middle game, that's realization, that's a construction. Lots of people are doing this, and this is one of the most central part of the software development because you need to produce something. That's where stuff are produced. And end game and maintenance in chess, this is basically when you end the game, and in large-scale software systems, maintenance and evolution is the largest life cycle phase, which means that a large-scale software system, mission-critical software systems, lasts for decades. You are not just throwing out those huge software because these are incorporated in very heavy business processes. You cannot just retire a software and come up with something brand new because you disturb the whole business, right? So everything here then cycles around in the context of maintenance and evolution. And that cycle goes on, goes on, goes on, which means the next cycle, next feature, next project builds on the previous one, and then your software evolves. Types of the software system, this is important to understand in order to know what we are dealing with. There are 3 different types of the software system. One is the S-type, which is a software system where everything is well-defined from the very beginning. The rules are not changing. And for example, course exams, assignments, project assignments on universities and this kind of stuff, or a tic-tac-toe game or putanula, as we know it, that's a famous S-type system because it's simple enough, you can enumerate all combinations and come up with an exact solution for the software. The next one is a P-type system. A chess is a good example, where although the requirements are stable, fixed, and well-defined, the domain is so complex that you need to use heuristics. You cannot enumerate everything. And E-type system, that's the systems we are dealing with. This interacts with an environment. If you, for example, develop a software system which is dependent on some laws, like finance laws or privacy laws, then of course anything that changes in the environment you need to address in the software. Besides software types, guys, 2 more slides of this dry talk, and let's do it together. Types of the software maintenance activities, okay? There are 4 of them, which are categorized in big 2 categories, correction and perfection. So we have a corrective, that's a bug fixing, typical bug fixing report. Someone reports a bug, you fix it, and that's it. It's a passive, reactive way of enhancing the software. Then we have preventive. A preventive action is when you notice something proactively without waiting someone to report you a bug. You, in advance, address that bug and not allow a fault to turn into the failure. Because a fault, guys, is just the potential for a failure. For example, if you have a routine or a function which divides by some number, and that number, if that number can be a 0, that's a potential fault. And whether a fault will turn into failure depending on how someone uses that function, about the use cases, whether someone will hit your function with 0. That's when a fault turns into the failure. And preventive is when you proactively see, hey, we have the huge luck, nobody called us with 0, so let's fix it, okay? That's preventive. Adaptive means to keep the software usable. And software, large-scale software systems needs to be all the time adapted to environment, otherwise it becomes useless. And perfective, this is basically working against entropy. This means that we enhance the quality of the software because over time, and that's the laws of the program evolution, Lehman-Belody laws of programs evolution of large systems, says that when you add features, you will basically deteriorate the structure, internal structure of the system, so you need to make something and to maintain it. And the total cost of ownership of software, that's also very important, and that's the last slide. You are good guys. Having a patience to go over this. So we have the initial development of the product. That's usually what you are used to, okay? Start from scratch, develop, first version, done. Then we have enhancements activities. We have just listed them, corrections, and customer support. Now, this first guy is development, and these 3 are maintenance and evolution. So the relationship is 3 against 1. So which means that most of the things what happen in software is about maintenance and evolution, which means beware of being fast at the expense of quality. Because many companies are very fast pushing out the first version without taking care what is the quality of that first version, whether that first version is ready for evolution. And imagine a situation, you push the first version of the software system, you gather lots of clients, they start to ask you a lot of enhancements, and then you just say, please, my software is not in a position to be changed. Okay, so then what we are going to do with the client base? And invest in people before anything else, okay? That's the golden rule of quality in every software company is invest in people, because human factor, there can be a 10x difference between developers, and that's the most important thing. Okay, now we turn to this role of rules, principles, conventions, and standards. Now the talk starts to be a bit more lighter and more interesting, okay? So I congratulate you that we have managed to go over these dry things. Okay, so this is the Zen of Python. How many of you have executed import this? Oh, good. Okay, how many of you have contemplated about each of these stuff? What does it mean? Okay, cool. I have contemplated also, and I made this talk, so then we will be able to sync up later whether our thoughts were the same or different. But anyhow, these are the rules, some of the rules, okay, enlisted here. And there are rules, principles, laws, standards. These are all different manifestations of some wisdom, some knowledge, which is synthesized in a very effective, powerful, short messages to reach as many people as possible. And principles are like rules, but just stronger, or laws even stronger. Standards are having organizations behind them. So every of these things are going to be exemplified. Not in a way that we pick up one rule and say, aha, here is the example for that rule. That doesn't work, okay? Software engineering in large-scale software systems is a holistic approach, holistic activity. You need to have a full picture of everything comprising a software. You cannot just pick up one thing, analyze it out of the context, and then put it back and say, okay, I am good. For example, these two rules, beautiful is better than ugly, although practicality beats purity. This means these two rules are interacting, which means the rules should never be treated like what? Like dogmas, okay? We are not should not be dogmatic about rules. Rules are there to help us. And these two rules says, for example, this is an example, if you are used to do this kind of comments, this is non-practical. It's beautiful, but we are not in a fashion industry, we are in a software industry, right? We sell software, not beauty, although it's nice to have beauty as well. But this says that rules should not be treated dogmatically. This is about maintainability. For example, readability, one of the main core activities what developers will do during maintenance and evolution. You will read someone else's code, you will need to understand someone else's code. And this is the standard quality model 25th 010, and analyzability is directly connected to readability. This is a meta rule. This is a meta rule. This rule says how to treat these rules, okay? So special cases aren't special enough to break the rules, okay? A meta rule about the list of the rules. Okay, enough of this. Let's start talking something concrete. Now, these rules, everything, rules, principles, standards, cannot live or cannot be in an industry without what? Without tools. So there are lots of tools supporting you in order to enforce or to comply with standards and rules. And for example, PyLint is one of the tools, for example, having this code style checking, and this is the style guide for Python code. It can do reverse engineering, generate you UML diagrams, integrating the PyReverse. It can refactor, it'll help you during refactoring, detect duplicated code. ID integration, it's nicely integrates with Spyder. I will show you a couple of PyLint outputs later on. Error detection, and that is lots of customizable checkers, which computes many useful metrics for you to help during your endeavor. More tool support, don't want to mention only one. For example, Codesy automated code reviews, Code Factor, again, automated code review. What does it mean, automated code review? You check in some code and the tool kicks in and starts to give you feedback, and even you can build it into your continuous integration, delivery, and deployment pipeline so that you can even stop the pipeline and do some actions if the quality is endangered. Then is Radon tool, used by all of these. This has a McCabe's cyclomatic complexity. How many of you have watched about cyclomatic complexity in his code? Okay. So, row metrics, and you see here, these row metrics, for example, number of comment lines, number of blank lines. There was one rule in the Zen of Python, sparse is better than dense, okay? That rule says, make your code not packed up and dense, because that would negatively impact readability. Halstead metrics, maintainability index, and so forth. And this guy, MyPy. How many of you have used MyPy? Okay, you know what? This guy here, this MyPy, And this static type checker for Python, guess from where it comes? It comes from the experience of working with large-scale software systems. Because it's proven that statically typed languages has advantages over dynamically typed languages when it comes to maintaining and controlling a large code base. That's the reason why guys started to, and that's the impact and influence when Python entered the mainstream and as an enterprise language, it needs to address challenges of that enterprise. And all these tools calculates qualitative or reports you about qualitative aspects based on quantitative proxies. Okay, that was a mouthful. Sorry for this, but for our slides, it's a perfect text. And tool can only report and act upon efficiently measurable indicators, which means that the tool can measure only what can be quantified and what can collect data. But as the examples will show, this is only a small part of the whole picture. So being seduced into thinking that if the tool said the code was okay, it's okay, is a false assumption. So tools are only capable of collecting what they are implemented for. That's a valuable, a very useful set, but it's not the whole picture. Context awareness and communicative abilities. Guys, developers and all large-scale software systems are about people. Now, people, there are different peoples, and in the large-scale software companies, the context awareness, and this is one of the guys and the model which says context and knowledge oblivious. So we will start with this guy who doesn't care about what happens in the surroundings. He doesn't have limited knowledge. He gets a task, and that's the sequence diagram, task from an issuer. An issuer can be a management or whatever. And then he make up ad hoc rules, principles, apply limited knowledge, and just goes on. Now, this is a type of developer which is very dangerous. I had as a consultant, I had an experience when in one company everything worked perfectly until something was broken. And it turned out that many, many releases before, some guy raised the thread priority on the highest level and used that fact to synchronize his own stuff until someone else in some other team decided the same thing, and his thread was not anymore the highest priority, and everything fell apart. That was a typical person of context and knowledge oblivious. And here is one example. Okay, guys, we start with examples. Okay, something. Okay, here is a very simple code. Okay, very simple code. And by the way, in Zen of Python, there is a very golden rule: implementation needs to be as simple as possible. The same is for talk. If I cannot come up with the dumbest, simplest example to explain you the concept, that means two things. Either the concept is vague, or I have no faint idea what I'm talking about, okay? And the reason is that the examples are that small and that simple means that if something works on these trivial examples, then be sure that it works and kicks in even with larger software. So we have a sorting routine here, very simple. And someone in a company, in a huge code base, say, okay, let's, guys, reduce complexity, cyclomatic complexity. And then a guy comes up with this code and starts scratching its head how to reduce the cyclomatic complexity, because the management said we need to reduce everything what we can. Guess what? How would you reduce the cyclomatic complexity of this code? Sorry? With a sort function. That's okay with the sort function, but that's just, putting one indirection in the picture. And guess, suppose, okay, this is a shortest. Suppose that you don't have a ready built-in function, but you need to reduce the cyclomatic complexity. But this is a good comment, yes, for sure. Well, the guy scratched his head, and he decided, and this is, by the way, a PyLint score. Notice 1.67 is the out of 10 for this code. And there's a quite useful suggestions what needs to be improved here. But the guy looked at the if and decided, let's remove the if. And this is a version of the sort routine without checking the conditions, okay? So it's an if-less sort, okay? It's puzzling, okay? So I'm calculating arithmetic. It's an average, so it's quite puzzling, but it works. Okay, it works under apostrophe. Look at this guy here. So it doesn't quite work, but guess what? The cyclomatic complexity is less 1 than the previous version. And what the tool reports, 3.75 out of 10. Wow, that's more than double. And now, if you're just looking at the tool, you would say, oh, this was a great work. Excellent. Cyclomatic complexity went down. Global evaluation score went double up. Should we blame the tool? Of course not. The tool is doing just his job. The tool doesn't understand the context. The tool doesn't understand what happened here, okay? And that's the reason what happened here is a failure of the core basic mathematical logic, okay? And that's here. Implication is not equivalent to its converse. What does it mean? A less complex code will produce a lower cyclomatic complexity. But just a fact that you lower the cyclomatic complexity doesn't mean that you will end up with a less complex code. And tools alone are not enough. People are the users of the tool. You are responsible to drive the tools, not vice versa. Because if the tools drives you, then you have a huge trouble. And believe me, in large organizations, this automation hype about let's automate everything. Let's treat people like dumb cogs and replaceable cogs. And our automation facility is so good, it catches everything. That's a false view, okay? That's good for maybe having a false, kind of a belief, and then maybe it's a stress reduction technique for management, but it doesn't work in practice. And now we come to a guy which is context-aware and knowledgeable, and this guy asks questions. And the question is, and the problem formulation, that's on this remote island. Believe me, guys, asking right questions, formulating the right problem is the most difficult part of the endeavor. And by the way, these nice pictures, do you know from where they come from? If you're not, then if you do your presentation, pixabay.com provides you a Creative Commons license, and you can use these pictures. And if you have your good pictures, you can upload and then share with the community, okay? So this guy knows how to ask questions. And this question, this interaction between the management and the developers, that's the most important thing in a successful enterprise. If these loops are broken, nothing else matters. Now I will take this heavy, hardish job, risking losing all of you, to exemplify two major ways how in companies these loops can be completely destroyed, okay? One is have time to ask. You need to have time to ask questions. And you know what? You are under control whether you are going to have that time or not. And the second one is know how to ask. You need to speak a right language, otherwise, again, you will fail. So let's see first this have time to ask. Okay, because if that loop is broken, you will just end up with a knowledgeable person who will not ask any more questions. Because he will build up a wall and say, oh, talking to management, don't talk to management. They won't understand you. Believe me, I tried, don't talk to them. And the management will, again, talking to developers, come on, I have talked with them, they started to talk about some technical mumbo-jumbo. I haven't understood anything of them. So let's see how this works. This is a picture from the cone of uncertainty from, here is the link from Constructs. And this is, first of all, saying about what happens in a large software from the very beginning to the end. Now, this cone of uncertainty is about estimation. How many of you know the difference between estimation and commitment? Okay, so what happens is, you see, at the beginning of the project, when everything is fluctuating, nothing is fixed, there can be a huge variability of factor 4 go up and factor 4 down, which means that these areas here at the beginning is very dangerous to make a commitment. And how this goes, a manager comes to you and asks you, what do you estimate on this area of that this work will need to be? And then you say, okay, well, let's see, 1 month, okay. He puts in his project plan a 1 month, okay. You made a big error that you have communicated a guesstimate into a commitment. That's your fault. And then once that deadline is put into the project plan, that's over. Because then the companies are making a budget is planned according to that, everything, And that's basically gives you a path to a disaster. These here, product definition, data requirements, user interface design, these are more or less risk reduction or risk mitigation techniques to reduce this uncertainty. In a well-managed project, this uncertainty is having this shape of cone. Uncertainty over time is going to be smaller and smaller. In a badly managed project, you would have all the time uncertainty huge. So this is an area where you should not make commitments. This is the area where it's okay to make a commitment. And if you make a commitment in this area, then you will hit 2 things. First, if you overestimate, okay, that makes an undercommitment, which makes a very low pressure on developers. And there is a Parkinson's law which says that every people will fill out his time with something. And then you will end up with a moderate quality. But if you make, which is typically the case, exponential penalty, underestimation, you will have an overcommitment, extreme pressure, and low quality. And here, with no penalty, we have optimal pressure and high quality. So this is the first thing that you have to learn to resist the temptation to promise and commit yourself when it's very dangerous to do, if you haven't reduced enough the risks. Now, the second thing is how to ask questions. Okay, here is the small routine. It contains a bug. Maybe you will notice it, maybe not, but this is a documentation here, and that's what is underlined, is what it's supposed to do. Now, oh, sorry, what happened? Oh, okay. Issue discovered and reported, okay, good. Work estimated, issue assigned and prioritized. That's a standard thing when something happens, okay? Corrective, fixing bug. Now, you take this code as a developer and start fixing a bug, and because it was work estimated to be a very small fix, you are writing proper unit tests because you are using test-driven development, fix the bug and let the test pass, assess status, and deploy a hotfix. That's your tasks. Okay, you end up with a test case and you make up a unit test for catching the bug. And this test identical, this is the test which will fail because the code had a bug. It doesn't matter if you haven't noticed the bug, but it was basically the way how it worked is ignored completely because of the way how it assigned variables. And this is a fixed code. And the previous version had 1 temporary variable. Now this has 2 temporary variables, 2x, and another one is temp. And guess what? The code is, does it have proper unit test? Yes, of course. Is it everything is passing, setting the status? Okay, everything cool. Most of the time, this is where the story ends. But my question is the bug fixed? Look at this code. This code is more F-full than the original version. The documentation nicely pictures out what the code is supposed to do. And look at the implementation. It's brutal. It's bags for cleanup. Okay? Now, you are a developer, a very knowledgeable developer, and you don't do this. You spend more time about thinking about whom? About your teammate. That's the whole picture. You think about others. If others will touch this code, whether they can understand it, whether it's readable, it's not about you anymore. You are working in a large enterprise. And then you end up with this code. This is a simple but needlessly complicated code. The Zen of Python says complex is more better than complicated. Okay? And this is a complicated code. Simple but complicated. And you end up with a nice fix for this same error. And look at this code. This code is absolutely encoding the formula there. Clean, understandable code. You just need to think differently, that instead of doing from the forward or from the beginning, you vice versa repeat it. But now comes the story. How you spend more time on the bug fix. What are you doing? You are spending company's money. Okay? And the manager comes and asks you, okay? Managers are not evil, okay? Managers are also worrying about strategic interests of the company. Without a management, you won't have money to develop anything. But you as a developer needs to respect that effort and need to know and explain what's going on here. But here's what the developer usually says. This is a red list. Oh, I have eliminated 2 temporary variables. I am a guru. Developers usually talk in technical terms, okay? That's what they are excited about. Then, the code is now beautiful and fully aligned with the embedded documentation. It's faster, doesn't matter whether it's important or not, it's faster. It uses less memory for 2 temporary variables. It has fewer lines of code. And I have improved the global evaluation score from 4.4 up to 5. Now, what do you think the manager will say to you? Money was spent on nothing. Nobody approved you to work on this. Should we blame the management? Of course not. I mean, these are all mumbo-jumbo, technical mumbo-jumbo. It doesn't matter. If that's your responsibility, how would you translate your language in terms of management? To keep up with knowing how to ask questions. Now, here is the list. Okay? That's what you need to do. And you need to know software engineering economics. How many of you know about software engineering economics as a knowledge area of software engineering according to IEEE? How many? Wow! That's what I guessed, and that's why I put this into my slide. That's the biggest obstacle for you guys who are young to succeed in large enterprises. Because that's the way how you cannot speak the language of business. That's the way how you can completely throw out yourself from the global picture. Because on the meetings, when the CEOs talk about strategic objectives of the company, about the financial structure, developers usually treat those meetings just one of those that I need to survive. And then poking around the mobiles, sending SMSs and all sorts of stuff. But that's the most important meeting because that's the perfect opportunity for you to understand what are you doing in a company, how your work is aligned with the core business objectives. And then when time comes, then you will start talking to management in the following way. Okay, by the way, software engineering economics is the science of choice, okay? To resonate and express opinions in terms of business. What are these? I have spent T1 time to understand the original idea. Keep in mind, that I am talking about high-level terms and expressing what I have done in money. Time is money, okay? Management knows if you spend T1, how much does it cost? Then I have spent an additional time to refactor the code to improve maintainability. And that's no new risks were added. Software engineers and developers are traditionally bad in risk management. They don't even care about. But the management is only caring about risks. Okay? The code is central to the core functioning of our system. That's where you as a developer know your role. You need to know your role and how your work impacts the business. Other developers, and that's very important, other developers will only need to spend T3 time to understand it, where T3 is, I'm making up these numbers, let's say 20% of T1. And then you finalize the talk. The return of investment is the maintenance savings, refactoring cost, and this is the formula. And then you say, okay, T1 was 4 hours, T2 was 7 hours. You know what? 3 developers to look at this code, and the profit or the return is, and then everything else is a profit. Guess what you will say? Good guy, you are a champ. You balanced your time and money of a company. You explained to me clearly what you have done, and that's the path to a success. Because if the management starts to think about developers as unresponsible guys who will do something very weird when they have time, then there will be a micromanagement and control and command and control enterprises. But developers are responsible to keep the ball rolling. Okay? Here is a bonus. A new developer, solved this same problem using NumPy. How many of you use NumPy? Okay, cool. This is how in NumPy would you solve in a vectorized fashion. Okay? Now the management will ask the same question. You have spent money. And now the developer who doesn't know how to speak the language of the management, guess what he will say or start with? I have solved the problem with NumPy, which is nowadays used by everybody. Oh, I am a cool guy. I know about NumPy. I have solved the same problem with NumPy. Okay? I have eliminated the for loop. Oh, great. The code is much faster and due to vectorized operations. And this function will serve as an example for others about NumPy. Guess what will the development management says? So this madness won't stop here. Now everybody will NumPying around? Are you crazy? But what should the developer say? Okay? Guys, these are examples which I really reduced to a minimum form. But as a consultant, all the time, you can experience in big companies the same problem. Developers will group and make an isolated silo, talk about the managers who are guys who don't understand anything. The managers will talk about developers or someone who needs to, you need to control that guy. That guy is dangerous. Don't allow him extra time. He will make crazy things. Okay? They will treat you, they will think that you are a threat. And here is what the guy should say. Okay? After time T, I have improved the performance of a critical part of our product. Based upon profiling, I am not guessing, I know. This has created a performance budget that was missing up so far. That means that this developer knows about performance budget, this developer knows about architecture, these developers know that this is a critical part of the product. And what is an architecture? This is basically this. This is definition, by the way, my definition, and I will cite my book later on. But, so take this with a pinch of salt. It's my definition, so you are warned. So it's about non-quality requirements, okay? And performance budget is how performance is distributed across modules. And then he continues, the function's higher speed increases the throughput in processing client requests, and this generates more money because we don't lose clients in peak times. So this developer exactly knows what this code will impact and what part of the product it will impact. And then NumPy was introduced with minimal risks. And guys, this is the very most important thing. How many times you have imported some framework just because you have found some cool stuff that you needed at that moment? Okay. So you need to make a risk mitigation strategy and say to the managers, because when the management is informed about it, we have imported something new. That's a risk, okay? But then you can say, it's a popular open source framework. It's well maintained. You go to the GitHub, see the commit logs, how it's maintained, well documented. I am an experienced user of this product. So there is no training time, consultants extra time, because that's important. If you introduce a framework, make sure that either you are an expert of that framework or you know someone from a company who is an expert. Don't introduce a framework and then when a management says, who is an expert for this? Oh, nobody. But you know what? We can read about it. I found so many good books. Don't worry, I'm reading fast. That doesn't work, okay? And again, if you do this, you're a champ. Okay, reverse engineering, re-engineering, and construction. Now, this is all the time spinning in a software industry. You need to recover the documentation, recover the design decisions, and then restructure the code and implement the feature. And all the time you do refactoring. And this is a detailed reverse engineering flow where you make hypotheses about behavior, analyze the determinants of the system, and refuse or reinforce or refute hypotheses based on what you have discovered. And this is the puzzle one. This is the code. Again, we are talking now about legacy code, okay? And legacy code is more or less like this. They are puzzle, okay? Puzzle there. You don't find automated tests. You need to reverse engineer. What you are going to do here? Okay, you fire up, start up the code, and you notice external behavior. And you figure out very easily what's happening here, because this guy here is actually that guy there. It's an integer square root, a highly optimized, very fast integer square root routine. Now, the question is behavior all that matters? Can you throw out this code and just replace with that one? If you would have documentation about everything here, okay, had puzzle been renamed to I square root, would that help? Or maybe would that help if I would send you this link which explains in detail what the logic of that code? Well, it turns out not, because all the decisions which were made when this code was produced is sitting somewhere else. It's not a code documentation. Maybe this code needs to run on a constrained device. You don't know. If you throw it out and replace it because you think that it will work, then you can blow up the whole thing. Second puzzle. Again, a code which does something, you don't know what, and then you try it out, and you get these very strange numbers, 4, 3. But you have, by analyzing this code is much more amenable for analysis. You can come up with some very good hypotheses that this code is spilling out the index k, which splits the numbers in half of the amount of numbers are on left side and on the right side. But something is wrong here, okay? Now, because something is wrong, this means that this code has a huge discrepancy between the intention of the developer and what's coded up. So this is a code with an error, okay? This is not a bug-free code. So a story that you can reconstruct everything by looking at the source code doesn't apply here. Because if you start to experiment and change these guys here to somehow force the code to do what you are supposed to, you have hypothesized what it does, then if you change this, you will get this. And you are lucky and you are very happy that, okay, my hypothesis was correct, and this is what I came up with. But then someone asks a question from you about these two guys, and you give up because you cannot answer these questions. Irrespectively how many more time you are going to experiment. Because all what you can do is come up with one hypothesis or the other and put a code to comply with one or the other. But you never can decipher what was the original intention of the developer of this code. Which means, again, just looking and documentation by itself, it's not only about documentation, what you put here on architecture. Test cases are also documentation, right? So we come to this puzzle. And this is a reverse engineering puzzle. I am all the time giving this to my students. And what's the number here in the door? What should be replaced by the question mark? Well, here is one solution. You sum up the digits on this side and come up with a number on that side. Cool, okay. That's one hypothesis which works, right? The same thing. We have looked at the code. This is another solution. Just a different way of thinking. And by the way, nobody can argue at this moment who is right. Because both guys can explain very logically, my answer of 15 is correct. The same will happen with, then comes this, 22.8. And then a question for you. Can you explain the rationale for 20 or 16? Address of the home. Excellent. That's the same thing what one of my students told me. Bravo. Have you talked to that guy? So, these houses are on even number side of the street. Forget about windows. Forget about everything. Okay? But guess what? The same thing happened here. We had absolutely a reasonable logic, but with absolutely reasonable logic, we still cannot answer the question because we are missing that small detail about the direction, whether numbers should increase or decrease, and we are done. We are game over, okay? The importance of APIs, 5 more minutes and I am finished.
Time's up, kind of, but you can have a few more, I guess.
Sorry?
Time's up, kind of, but yeah, you can have a few more minutes.
Yeah, 4 more minutes and I am okay.
Yeah, okay.
Because, it was...
Then we don't have time for the questions. But
Sure. Okay. APIs, importance of APIs, okay? This is the role of an API, to be a gatekeeper, protect clients from internal changes there, protect system against careless usage, allows managing technical debt, which means that if you have a clean API and come up with a clean API, clients will use the clean API. You can then work behind and improve your code base. If you come up with a botched code base and ad hoc API, you will turn the mess over to the clients as well. And that's a technical debt with an interest rate. And also prevents entropy from flowing from one side to the other. And here is a formal, very mathematical definition of how to design APIs. So you have an entropy of the system, okay? This is, again, my version of the musing documented in the code, in the book. So you have some kind of a system, hypothesis of a system, okay? And you calculate the entropy of your confusion about that system. Without an API, you have a black box, and you are absolutely confused about what's there. The entropy is, okay, large. Then you say, okay, I have an API. An API is just a set of artifacts, mostly abstractions. I want to have an information gain from API, which is an information gain from a system S. Having an API is a reduction of the entropy after I know the API. So this is a conditional entropy here. How much my entropy will reduce knowing the API, which means a good API reduces the entropy. And ordering of AI is consistent with the law of diminishing returns, which means that if you give me a package name, the package name should decrease my entropy or my confusion about your system much more than some hidden detail in the code base. Okay, so that's the gradation of the abstractions from most important to least important, and then information gain with the CDC. What's the CDC? Consumer-driven contracts. It's an union of API and CDC, which means a CDC is this. You have a wire which is radiating all over the place as a bad API which has many assumptions left open. You then hypothesize about what your system is doing, and you have crosstalk, which is like an emergent property of the system, and what the consumer-driven contract is doing, making this wire to look like that one. Which means, for example, if you have noticed, and nowhere is documented, that a system will always initializes the state to 0, and you have found it out, nowhere is documented, then you can make a test case, a documentation, sent to the company that you are one of his clients who are assuming that emergent property. And then that emergent property will become the API of the product, okay? You have closed down one piece of the API which radiates. And this is an evolution of the API of, here is the calculate integral of Riemann, you f, a, b, and dx. dx is an implementation detail. If you do this, the API design, then you will basically sync or this implementation detail, dx, will come up to the surface. And if a client would ask you to implement a better integral, then what you can do? In order to keep compatibility, then you have said dx none, n equals none, and then look at how many frameworks in Python, very popular frameworks, have this way of handling compatibility. A better way is to have a portfolio and evolve the API as a portfolio. And this says that I have a stable API and I pushed the differences in a completely separate class. Okay? That's a stable API, which means it's not that I am fixing the API, I am just controlling its evolution. And this will end the talk, okay? This is where we have, I have more slides, but guess what? I have said I modeled the number of slides, and okay, I was pessimistic, should have been I was too optimistic, sorry. I prepared more slides than running out of time. Thank you very much. We together survived this talk. You are a fantastic audience, and I hope that we have some time for questions, right? Okay, if not, then...
Okay, so can we get a round of applause first? So as for questions, we are kind of right now in the time where we need to go for a coffee break, which is 10 minutes. So if everybody who wants to like listen to one question being answered, raise your hand. Come on. Okay, everyone's... no coffee break. You can do the first one. So the question is, are there studies that found a correlation between using PyLint and similar and producing good software based on measurables? Example, number of bugs, hours employed, turnover rate, etc. If you could provide some references.
Yeah, I mean, this is absolutely. So all these tools are developed because all those metrics are useful. So they were not developed because those metrics are useless. So applying these tools for sure can help you, but you have seen the example in what way. So if you apply that tool in that way, then basically everything what you can find, the references, I mean, take any software engineering book about quality, software quality per se, and you will find those stuff. Every metric is scientifically published stuff, okay? So first the academia published that metric and then came everything else.
And 20 seconds for the next one because we're really interested in why not teach managers what they're managing and not making developers spoon feed the managers. There is less managers than developers in any company. So 20 seconds.
Why not tech manager? Why not teach managers what are they managing? Okay, you see, how many managers are there here? Okay. Okay. So they can confirm or not. The management, of course, when we talk about these communication problems, that's for sure the responsibility is on the management as well. So managers should know as well, or anticipate, that developers will start talking in technical terms. So it's then also on the side of the manager to start asking the developer about things what is important for the business. And this kind of things is not about teaching XY manager. It's about changing the culture in the company, and that's a huge undertaking. But more and more companies are having a split management, a technical management and other management. So the companies have realized that one single, one-size-fits-all management doesn't work. And that's why you have a HR management for human resources, you have a technical management line, a strategic management line. So that's not true that managers are not catching up, okay? So the management is also catching up, but since more developers are there than managers, that means that more are lying on the responsibility on the developers to proactively make their life better in a company for the mutual benefit, okay?
Okay, thank you very much.
Yeah. Thank you. I was presented this conference, the talk, the Zen of Python in Action. It was my first conference of this type. Usually I took place as speaker on scientific conferences, but this was a completely new experience. And one of the reasons that I decided to go here on Python, to talk to young people, especially to developers from the industry, and to touch base with them as much as possible. And I hope that they liked the presentation. According to the reaction of the audience, they were quite tentative, and in that sense I'm very thankful for this wonderful opportunity to talk with the Python developers.